In this demonstration, we are going to build the starting structure for the Menshutkin reaction transition state. We will optimize the structure when it is complete. We begin with a new view window in Gauss View. We then open the element fragment and select iron, specifically the trigonal bipyramidal form. You may think this is an odd choice given that there's no iron atom in our structure. However, using this fragment is a very quick way to get exact number and arrangement of connections to the central atom in our target molecule. This alchemical shortcut is often very useful.
Now modify the axial hydrogen atoms to be the correct elements, a nitrogen atom and a chlorine atom. Change the central iron atom to carbon, and the element fragment window can now be closed. Finally, add 3 hydrogens to the nitrogen atom.
The next step is to modify the bonds connecting the heavy atoms, changing both of them to half bonds. We do this to indicate the nature of the bonds to Gauss view. When we clean the structure, the bond distances between the carbon atom and the heavy atoms increases. Next, adjust the orientation of the hydrogen atoms on the nitrogen and carbon atoms. Do this by modifying one of the H, C, and H dihedral angles to be 60 degrees. It doesn't matter which one we select, as they are all equivalent. Our final step is to ensure that the molecular structure has the proper symmetry, which in this case should be C3V. We open the point group symmetry dialog. When we enable point group symmetry, we see that our structure already has the desired symmetry. If this had not been the case, we could have used the items in the central area of the dialog to impose the C3V point group symmetry on the structure.